Hi ladies and gents, this time we're going to talk about arc length. Arc length is defined as the distance along the outside edge of a circle when it is rotated through an angular displacement of theta. So let's say I have got an object that is rotating in a circle. If it rotates through an angular displacement of theta and r is the radius, then S is the arc length. That is the outside edge of that circle. Now, the arc length is a length, and so that's going to be measured in meters. R is the radius, also going to be measured in meters. And theta is my angular displacement, how far something has rotated, and that's going to be in radians. So write this equation down, put it on your formula sheet. That's one we're going to use. And matter of fact, we're going to use it right now. So here's a classic example of where this is handy. A car travels 10 miles. The tires on the car have a diameter of 27 inches. What is the angular displacement of the tire during this journey? And how many times does the tire rotate during this 10-mile journey? So here's what's going on. Here is my tire. It has a diameter of 27 inches. That's my diameter. So I have to take diameter divided by 2 to give me radius. So 27 inches divided by 2, I'm going to get 13.5 inches is the radius of my tire. And the car travels 10 miles. Now what that means is if you had a little dot on the outside edge of the tire, it is going to travel around and go through a complete arc length of 10 miles. That is the amount of physical distance that a dot on the outside of that tire, the actual surface of the tire, is going to travel. So my arc length is 10 miles, and I want to know theta. I want to know what is the angular displacement of the tire. Now, this is like learning a new language when you start going to the rotational world. So pay attention to the words very, very carefully. That's where I have a tendency to get confused. My equation for arc length is theta is equal to S over R, and these two must be in the same units. So this is in inches, this is in miles. We've got to go in one or the other, but I think I'm going to convert miles into inches, get rid of miles. There's 5,280 feet in 1 mile. I know that from elementary school days. And I'm going to get rid of feet, go to inches, and there are 12 inches in 1 foot. So when I do the math on all of that, I get 6,000 inches. Now you might say, why do you have so many sig figs? Because each one of these definitions is exact. They're like a counting number, and so they do not contribute to my number of significant digits. So that is how many inches I'm going to travel. That's my S, my arc length, 6,336,000 inches, divided by my radius, 13.5 inches. When I do the math, I'm going to end up with 46,933. Now watch what happens. I've got inches divided by inches. That should cancel. But because we're dealing with angular displacement, on this is radians. This is one of the things that's going to make you a little crazy now and then. Radians kind of blink into existence and blink out of existence. You just have to keep your beans together to pay attention of where you can find them. The last part of the problem is how many times does the tire rotate during this travel? So I am going to erase, give myself a little bit of space, and we're going to just convert angular displacement into revolutions. So I'm going to change ink color. I've got 46,933 radians. I'm going to get rid of radians, go into revolutions. 1 revolution is 2 pi radians. So my tire is going to go around and around 7,470 revolutions as I drive it for 10 miles. That's our arc length equation. See you later.